Hello and welcome my grade 10 elite students. On your special request, I have brought one more video with the important questions that are going to help you for your math end of term 2 coverage exam tomorrow. So this video is from the part 2 of the exam coverage, and it is going to be having the important questions that are going to help you for tomorrow's exam. So stay glued with me till the end, and this is going to be my last video before your exam, so I would like to wish you all the very best. Make sure you like, share and subscribe to the channel if you have liked the videos. Thank you. Let's solve the questions on lesson 7.6 now, solving rational equations and inequalities. So I hope you can see the difference here. This is an inequality where you have greater than, less than, greater than equal to, less than equal to. So question 28, question 31, question 32, 33, 36 and 37 are inequalities where you don't have the equal to sign, you have less than or greater than. And the ones where you have equal to sign, those are called rational equations. And when I say rational, it means it has a numerator and a denominator. Okay, so we are now going to solve these questions one by one. And the concept that we are going to be using is the excluded values for the inequalities and LCM for the equations. So let's do question 28, 29 and 31st in the next slide. So for question number 28, we have to first in step 1 find the excluded values. Remember, excluded values are coming from the denominator. That means you have to look at the values of x in the denominator that are making the denominator 0 and then remove them. They will be excluded from the solution. So one denominator is x plus 4 equal to 0, so the value is minus 4. Another denominator is x plus 10 equal to 0, so the value is minus 10. So these are the two values which are removed from this question. Now we solve the related equation. So related equation means we convert the inequality this to equal to sign and then we solve. And then now we are going to be using the concept of LCM or LCD. I've already told this method to you before. So here you are going to multiply both sides of the equation with the LCM. So x plus 4 multiplied with x plus 10, since the denominators are different, their product is going to give you the LCM or the LCD. You multiply both sides with that and then cancel the common factor. So x plus 4 and x plus 4 is going to cancel in the left, and x plus 10 and x plus 10 is going to cancel on the right. Similarly, you get a quadratic equation on the left and quadratic equation on the right. Collect the like terms, simplify, cancel if anything is there, and then solve for x. So here x comes out to be 8. Now next step is to draw the number line and divide it into intervals. How I'm going to divide it into intervals? I'm going to first look at the excluded value minus 4 and minus 10 and plot them. And then I will put the third value, which is the solution. So we have got 1, 2, 3 and 4 intervals. Now for each interval you are going to put test points and check your solution. You are going to see whether which part of the interval is the solution true. So first you take x equal to minus 11, that is this interval. I'm going to just mark the intervals. This is the first interval, second interval, third interval, fourth interval. So this is from minus infinity to minus 10, the first interval, minus 10 to minus 4, then minus 4 to 8, the third interval, and 8 to infinity. So if I take x equal to minus 11 and put it in the equation, it is coming false. So this will not be a solution. Then you put x equal to minus 5, a point in between the second interval, and it comes out to be true. So from minus 10 to minus 4, this is a solution interval. Then you put x equal to 0, it is false, so this is not going to be the solution. Then you put a number here, x equal to 9, this is going to be a solution. So these two intervals are going to give you the solution set. Therefore the total solution is minus 10 to minus 4, interval 2, and x more than 8, that is interval 4. So this is how you solve the inequality. Now you are going to solve question 29 and 30. These are very easy because you don't have an inequality in them, you have equations equal to 0, so they are much easier, shorter to solve. So first you find the LCM or the LCD. There are two different denominators. The LCM is here 3k, so you take 3k common, multiply both sides of the equation with 3k, cancel the common factors k and k khalas, so 3 with 3 is 9, minus 4 equal to 0. Now this is coming as 5 equal to 0. Think about this. Is it possible that 5 be equal to 0? Not possible. So there is going to be no solution to this equation. Next is question 30. Again, we are going to solve using LCM. Both the denominators we have to make equal. So on the left, we take V. On the right, we take V. Cancel the common terms and simplify. So this comes out to be 2 multiplied with V minus 3 is equal to 5. Take minus 3 on the other side. It becomes 5 plus 3 equal to 8. Divide by 2. So there is only one solution. V equal to 4 in this case. Okay, let's solve question 31 now. Here again, it's an inequality. So you have variable n given here. So n plus 3 over n is less than 12 over n. This is the question. Now we are going to follow the same steps like we did in the last problem. So step 1 would be to find the excluded value, which I told you is going to come from the denominator. Denominator is equal. So denominator is n. So the point where n is 0 will be the excluded value. So there is only one excluded value in this problem. And now for step 2, we convert to the related equation. That means we are replacing the less than symbol of inequality with equal to, and again taking the LCM here, which is n, cancelling the common terms, converting into a simplified form. So the equation that we are getting is n square is equal to 9, which is going to give you two values plus minus 3. Step 4 would be to make the number line to divide it into the interval. So we are going to divide using the values 0 and plus 3 and minus 3. So as you can see, this is one interval, second interval, third interval and fourth interval. The first interval is from minus infinity till minus 3, then this is from minus 3 to 0, then 0 to 3 and 3 to infinity. So we are again going to take test points, put some value in between. Like for this interval, I'm selecting the value minus 4. It is coming to be true, so this is going to be a part of the solution set. For n equal to 1, the test is also n equal to minus 1. It is failing. That means this interval will not be the solution. For n equal to 1, it is true, and for n equal to 4, it is again false. So only solution set would be from minus infinity to minus 3, that is n less than minus 3, and 0 to 3, that is n lying between 0 to 3. So this is how you solve the inequality. Next is this one. Again, the steps are going to be same. So step 1, find the excluded value. Look at the denominator. There is only one value of m where the denominator is becoming 0. So m equal to 0 is the excluded value. Step 2 is to solve the related equation. So we are going to convert it from an equality to an equation. Take the LCM, which is 2m, multiply, cancel the common factors, simplify, and the equation that you are getting is 1 minus 6 equal to minus 5m. Simplify, so m is going to be 1 from here. Now you use the value 0 and 1 to divide the number line. So this is the first interval, the second interval, and the third interval. Take a test point. I take minus 1 for the first interval. It comes out to be false. So this is not a solution. Then I take for the other one 0.5, which is coming to be true. So 0 to 1 is definitely a solution. So m lying between 0 to 1, we select this, and this one is also false. So there is only one interval, which is the solution for question 32. Last but not the least, we have question 33, 34 and 35. As you see, the method to solve them is same. Here we have inequality, so we are going to find the excluded values. Then we solve the related equation. Then we divide the number line into intervals and give the solution as the interval which is true for the value. So which is this interval 0 to 3 by 2. Question 34 and question 35 are pretty easy because they are equations, not inequalities. So we are going to just take the LCM or the LCD, which is going to be x plus 2 multiplied with 4. Okay. because the different denominators that you see is x plus 2 and 4 here. So you multiply both sides of the equation with that value, 4 multiplied with x plus 2, cancel the common factors that you have, simplify the equation, and this value x comes out to be 10. Next we do question 35. Here the LCM is going to be the two different denominators t minus 3 and t plus 3, which can be written as this product. Multiply both sides of the equation with that term wise, cancel the common factors that you have, and what you get is an equation in t square. Again we are going to cancel t square from both sides, and we get an equation with a value t equal to 9. So there is a only one solution here. So remember, there can be one solution, no solution, or infinitely many solutions for an equation. However, for an inequality, the solution will always be intervals. Let's now complete these set of questions. The last two questions that are left are 36 and 37. So here again we have rational inequalities. We are going to follow the same steps. I hope by now you have memorized the steps. Step 1 is to find the excluded values. That comes from the denominator. So take the denominator t as equal to 0 and remove it. That's the excluded value. Then you convert the inequality to the related equation, and you take the LCM, multiply with the t on both sides, cancel the value of t which is common, simplify, and get your value of t as 2. After you have got the value of t as 2, you can do the division of the number line into the intervals. You are going to get 3 intervals here, and the solution set is going to be the 2 intervals out of these, the one where t is less than 0 and the other one where t is greater than 0. Next is the last question for today, which is solve 6 over m plus 5 greater than 2. This is a very easy question as you just have one rational expression. So the value of the denominator becomes 0 at the value m equal to minus 5. So that's your excluded value. Convert it into a related equation. Take the LCM, which is going to be the same denominator, that is m plus 5, multiply on both sides, cancel the common factor, simplify, and get your value of m as minus 2. In the next step, you divide the number line into intervals, taking the excluded value minus m and the value that you got minus 2. So there are going to be 3 intervals, 1, 2, 3. And then you take a test point in each interval, put it in the inequality which is given, and test if it is true or false. So if I put m equal to minus 6, what you are getting is false, so this is not going to be an interval. If I put m equal to minus 3, this is true, so this is going to be an interval. So minus 3 to minus 2 is minus 5 to minus 2 is definitely the solution set. So m lying between minus 5 to minus 2 is selected. And if you take a test point in the last interval, say m equal to minus 1, this is again false. So I'm going to remove this interval, and the only solution here is m lying between minus 5 to minus 2. So thank you so much for watching the video. If you've reached this last part, I would like to give you a humble reminder to like, share and subscribe to the channel. This is my last video before your math exam, and I would like to take this opportunity to wish all of you the very best for your tomorrow's exam. All the best and take care. Bye-bye.